Now that we're familiar with our laws of exponents, we are ready to take a look at some graphs of exponential functions. First, an exponential function, we need to label some of the pieces. This is just our function, so our function is f. The variable inside here is the variable that we are working with. And this is important, and I know it's tough to keep focusing on this and to ignore the fact that these do belong together, the names do change, and the variables inside change more than this semester, just calling it A, B, W, whatever it is you want to call it. Next semester, when you are working with functions, the variable inside here is crucial because outside here, you're going to have more than just numbers and that single variable. So we're trying to focus on that this semester so that you're not caught out next semester. This C is a constant, and the constant value, we have some qualifications down here. It's a real number, so it's not imaginary. And it's saying that it can't be 0. Well, if it was 0, this entire thing would be 0. So f of x equals 0 would just be the constant function of the line y equals 0. Then we have a as the base. And for the base, we have some constraints as well. It's going to be a positive real number. Positive because if it was a negative number, when your exponent is even, you have this function becomes positive or switches signs depending on this coefficient. And if the a is -1 and this exponent is odd, then this term of this function becomes negative, and so you're switching on and off on the signs. So you can't have a negative number, that's why it's positive. Greater than 0, because here when we have fractional values here, that will work. When we have whole numbers, that will work. When we have any kind of real number greater than 0, that will work. So that's that greater than 0 has to be positive that connects with this. Now lastly, the exponent. Here we have an exponent. And for the exponent, you'll look, we have a is positive real, that means it's greater than 0, it can't be 1. C is some real number, and C can't be 0. We talked about all that, but nowhere in here does it have a qualification on the exponent. So the world is yours and the fullness thereof with the exponent, but for our course we will be only working with real exponents, not imaginary exponents. Now we're ready to graph an exponential function. First, we take a look. Here's our function. We have a base of 3 and an exponent of x. Let's complete a table of values very quickly. For each of these, we're taking this value here for x and putting it in the exponent. So -2, 3 to the -2 is 1 over 3 squared, which is 1 over 9. And let's go through this really quickly. 3 to the -1 is 1 over 3. 3 to the 0 is 1, 3 to the 1 is 3, 3 to the second is 9. Okay, now we're ready to go ahead and graph. As you can see, as the negative numbers get larger negative numbers, here you're going to get an increasingly small value for the y value. So this function, as x gets more negative, the function is getting closer and closer to that axis. Let's go ahead and mark this point first, the 0, 1. So here at 1, it is hitting this axis, and it's coming in this direction where it's getting closer and closer. As it gets farther and farther out, it's getting closer and closer to this axis. But as the numbers get larger and positive larger, here these numbers are going to just take off, right? Because we're going to take each one and we're raising 3 to that power. So the exponential function then goes up here. We have a nice smooth curve. It is going to get close to this axis but not go up any farther. And so what's happening here, we have y equals 0 is what we call a horizontal asymptote. So y equals 0, horizontal asymptote. The domain is all real numbers. Remember, you can do that, or you can just write all reals. And the range is going to go from 0, but not including 0, all the way up to infinity. So we are going to get 0 all the way to infinity. Let's take a look at another exponential function. first, we're going to keep that f of x equals 3 to the x. We know that it looks like this, where it's hitting here at 1. And this is our table of values from the previous slide. Now, what they're asking us to do is take every exponent and add 1 to it. So instead of just -2, it's -2 plus 1, which is really -1. So we're looking at this value here. And then when you put a 0 in here, you get 3 to the 1, which is 3. And so what happens, all of these values are shifting in the direction so that our function hits 1 here when you have a -1 for the x value. And then at 0, instead of 1, 0, 3 to the 0 plus 1, here you get 3. And so this function has shifted this direction. So shifting it in one direction or the other does not change the domain for us because the function continues forever to the left and forever to the right. We still get all reals here. Now, for the range, we are still getting 0 to infinity because we still have that horizontal asymptote here. Y equals 0 is a horizontal asymptote, and you can mark it like that. Y equals 0. So all we've done by adding 1 to this exponent is shift it 1 to the left. You'll notice that this is really 3 raised to the x minus -1. And so that's telling you here, shift it 1. X minus the way you're shifting it, so -1. So if this exponent was x minus 3, you'd be shifting this thing 3 units to the right. And all the y values go with it as it shifts. The horizontal asymptote stays the same. We still have our original function, 3 to the x, where it hits here at 1 when x is 0, and we still have the same chart of values from that original function from previous slides. Now at this point, we're taking the function 3 raised to the x power and subtracting 2 from every y value. So take every y value that's here and subtract 2 from it. What that does is it shifts the entire graph down 2 marks on the y-axis. So instead of our asymptote occurring at y equals 0, it's now occurring at y equals -2, and that's our horizontal asymptote, which occurs here at -2. Our graph is still facing in the same direction. Instead of it hitting here at 1, that has gone 2 down as well, so it's now hitting here at -1. Still facing up, all of the y values down 2. So what's that look like for domain? The graph still exists for all x, and so that's still all reals. The range now is -2 to infinity because those values are approaching -2 but never touching and never becoming -2 and going to positive infinity, and that horizontal asymptote is -2. Another one, and this is our last one. Here's our original function, hitting here at 1 when x is 0. Now what we're doing, we have here a negative sign in front of the 3 to the x. So the y values are the same, except now they're all negative. And so we have 1/9, but -1/9, -1/3, -1, -3, -9. So as x gets larger, the y values are getting more negative, so it's coming down in this direction. As the x values get more negative, we're getting closer and closer to the x-axis. So this function looks like this, and it's hitting here at -1. So what we've done here is reflected across that x-axis. We still have a horizontal asymptote at y equals 0, so put that here. Don't forget to label it up on the graph. The range now is -infinity to 0. The domain, though, is still all real numbers. And all real numbers because we're allowed to put all the x values into our function. The y values because it's getting close to 0, never touching, and heading to negative infinity. So that's it. I recommend that you try graphing some more of these so you get a good idea of how they are shifting around. And I will see you on Monday or Tuesday, depending on the class you're in. Hope you're having a terrific weekend.